At any point, have you contemplated whether the universe had a couple of shocks at its disposal? Imagine a scenario where the astonishing things just deteriorated. The Webb telescope's most recent picture isn't simply a preview, it's an enormous stunner that is modifying the rules of our understanding. It is like looking carefully through a lens that disentangles secrets, revealing a universe more baffling than we ever imagined. This picture isn't just breaking limits, it's breaking our cosmological beliefs. If you are ready to think about everything you believed about the universe, then welcome to another time of inestimable discoveries, where the Webb telescope takes us beyond the known and challenges our grand beliefs. Stay tuned till the end. Concentrating on the evolution of the universe is crucial for humanity. Our craving to comprehend the origins of the vast universe has driven the development of disciplines such as astronomy and cosmology. These fields have provided us with valuable insights into the tremendous breadth of space and its heavenly wonders. Astronomy, one of the critical avenues of exploration, delves into the observation and analysis of celestial bodies, ranging from stars and galaxies to planets and beyond. It allows us to disentangle the mysteries of the night sky. Understanding the developments and behaviors of celestial substances, cosmology, on the other hand, focuses on the broader picture, the structure, beginning, and eventual destiny of the entire universe. By concentrating on the fundamental rules that govern the universe, cosmologists aim to sort out the puzzle of how everything came into existence and how it continues to evolve. The significance of these scientific pursuits goes beyond simple curiosity. As we unveil the mysteries of the universe, we gain a deeper understanding of our place in the vast order. The knowledge obtained from galactic and cosmological studies not only enhances our scholarly pursuits but also has practical applications, contributing to technological advancements and fostering a sense of interconnectedness with the universe. Researchers found that matter in the universe isn't spread out evenly. Some regions have more stuff than others. This discovery supports the widely accepted theory of the Big Bang, which suggests that the universe began from a singular explosive point, expanding and cooling over time. Evidence such as the cosmic microwave background, CMB, supports this hypothesis. The CMB is the lingering light from the initial moments after the universe's birth, akin to the afterglow of the Big Bang, persisting for over 13.8 billion years. As we learn more about how the universe develops and changes, our ideas about it continue to be updated because we keep discovering new things. Using advanced tools for research is a major help in sorting out the mysteries of space. These tools help us see things we couldn't see before and grasp how everything in the universe works. So, with each new device and discovery, we get closer to understanding the universe and how it came to be. Frequently, these revelations necessitate a change in current theories or the creation of entirely new ones. However, it becomes confusing when startling and mysterious events happen unexpectedly in the universe. These occurrences make researchers wonder if there's a mysterious force shaping the universe or if our basic understanding has been flawed from the beginning. The unveiling of new insights challenges established beliefs, encouraging researchers to reconsider and refine their models. Established scientists struggle with the significant implications of rapid, puzzling events that defy conventional explanations. Such moments force a reevaluation of our appreciation of the universe, raising questions about the very nature of reality. As scientists encounter the unforeseen, they navigate the barely discernible line between the known and the unknown, attempting to unravel the mysteries that continue to enthrall and baffle the scientific mind. One of these essential events was identified by the James Webb Telescope, the revolutionary tool in 21st century cosmology. What could it be? We should figure out the answer. But wait, just a little reminder before that. If you are new to the channel, remember to hit the subscribe button. Also, press the bell icon right next to it and stay updated with such extraordinary videos. Now, back to the question. The James Webb Telescope resembles a cosmic camera that takes marvelous pictures of space. It helps us look extremely far away into the universe, far beyond our Earth. The telescope's main job is to observe the farthest parts of the universe and examine stars and galaxies that formed just after the Big Bang. It's like a time machine, but for space. So, when we look at the photos it takes, we can learn about how everything in space began a long time ago. It's like a giant space voyager assisting us in uncovering secrets about the universe. Isn't that exciting? Now, the researchers, equipped with such advanced scientific tools, have explored the universe and uncovered various concepts like dark matter, dark energy, and the expansion of the universe. These ideas support the theory of how things came to be. For example, the theory of universal expansion proposes that the universe is consistently getting bigger. This means that galaxies and galaxy clusters are gradually moving away from one another. This expansion has apparently been occurring since the universe's birth around 13 billion years ago. Although various methods have been developed to measure or detect dark matter, none have proven entirely conclusive. The James Webb Space Telescope, however, offers a significant tool. Through its near-infrared images, astronomers can use these pictures to determine how much dark matter is present in specific cosmic regions. Moreover, gravitational lensing, another crucial aspect, contributes to this understanding. It explains how massive objects in the universe distort the space around them, causing light to bend as it passes through galaxies and galaxy clusters, thus inducing significant bending of spacetime. By observing the effects of gravitational lensing in Webb's pictures, researchers can map the distribution of dark matter in the vast expanse of the universe. Another finding involves planet-like objects caught in the Orion Cloud, a notable cloud in the Milky Way resembling the blade in the Orion constellation. Previous studies of this grandiose cloud hadn't uncovered hidden objects until the Webb came into play. One of the new discoveries, however, isn't just intriguing but also disturbing. According to Webb's pictures, over 771 trillion planetary systems have mysteriously evaporated from our universe. This implies that a colossal number of stars and their related planets have vanished, presenting an extraordinary event. What makes this discovery even more interesting is its potential to challenge our basic understanding of cosmology. Researchers are now questioning the theory of the universe's origin, as the disappearance of numerous solar systems conflicts with the principle that matter cannot simply vanish. The central law states that mass cannot be created or destroyed, but can change from one form to another. The astounding idea of this disclosure feels somewhat doubtful on laid-out standards, provoking a reassessment of our basic information in cosmology and stargazing. The ongoing comprehension of the universe depends on logical regulations, making it provoking for researchers to make sense of the vanishing of whole nearby planetary systems containing stars and planets. Some propose a hypothesis suggesting that these disappeared solar systems have gone through a transformation, becoming an alternate structure that is subtle to us. This hypothesis draws parallels with aging stars that, when unable to contain gases, explode into cosmic explosions, dispersing their mass as little particles across the universe. Anyway, questions emerge within the academic community, as the unexpected vanishing of stars without an observable cosmic explosion event appears unlikely. The massive effect of trillions of stars going through cosmic explosions would have resonated throughout the universe, influencing even our Milky Way galaxy. An alternative hypothesis considers the role of black holes in the mysterious vanishing of stars. Black holes, described by high gravity, can consume anything that ventures too close, including whole stars. Yet the size of this event raises questions, as it would require a massive number of black holes to consume trillions of stars, making it apparently silly to address. Researcher Beatrice Avroll and her group at the Northern Institute for Theoretical Physics in Sweden started the VASCO project. This exceptional project involves examining cosmic records to identify a star that once existed in the night sky but strangely evaporated in history, likened to the 771 trillion star systems. Finding such a star could provide insights into why it vanished and offer explanations for the current vast peculiarity. Up until now, no star matching the standards has been found. By the way, the VASCO project has drawn extensive attention from cosmologists, specialists, and experts across various fields. Some experts conjecture that a star possibly crucial for the venture may have evaporated without being initially classified due to the vastness of the universe. Despite the shortfall of a confirmed star, the team of specialists remains focused on the VASCO project. There's a possibility that a star vanished inconspicuously, testing the regular cosmic explosion process. Stargazer Lear Aravi suggested that certain stars could skip the typical cosmic explosion stage, progressing directly to black holes. Aravi cited a 2019 occurrence where a star in its last life stage quickly exploded and transformed into a black hole. However, the James Webb Space Telescope did not identify any black holes instead of these disappeared stars. Some in the academic community suspect a flaw or glitch in the Webb, suggesting it probably won't detect the light emitted by these stars. The Webb relies on infrared cameras to capture far-off objects, as the light from such articles is often redshifted to infrared. In the event that the star's vanishing is connected with light, it probably won't be the issue of the Webb, as NASA has not identified any problems with the telescope. The fact that the light from these stars is no longer visible to the Webb due to darkening or a change in the electromagnetic spectrum is a possibility. Different speculations attempt to make sense of the baffling vanishings. However, none uniquely offers a satisfactory explanation. Thus, some in the academic community have considered a controversial hypothesis: extraterrestrial activity as a potential reason for the abrupt disappearance of these star systems. The debate over the existence of extraterrestrial creatures has endured for a long time, with UFOs and UAPs serving as evidence for some and dismissed as legend by others. Lately, countries like the US have advanced compelling proof supporting the possibility of extraterrestrial life. Altering situations like the U.S. Congress hearing in July 2023 and the Mexican Congress hearing in September 2023 have rejuvenated faith in the presence of outsiders. Observers in the U.S. Congress shared shocking disclosures about UFOs and the government's association in reverse engineering extraterrestrial technology. Furthermore, during the Mexican Congress, evidence was presented that resembled extraterrestrial beings, similar to those depicted in 21st-century science fiction films. Regardless of these disclosures, questions remain due to the shortfall of actual footage portraying live extraterrestrials on Earth or anywhere in the universe. This raises issues about the credibility of the claims, driving many to doubt the existence of these creatures. Regardless of whether they were real, some consider how these extraterrestrials could make an entire star disappear. One possible explanation is that these vast creatures have advanced technology capable of manipulating stars for their own purposes. One way they could achieve this is by using stars to create Dyson spheres. A Dyson sphere is a hypothetical structure that a highly advanced extraterrestrial race could build around a star, essentially forming a round system to harness the star's energy. In this scenario, the star becomes a massive energy generator or battery, catering to the needs of the extraterrestrial society. The possibility of Dyson spheres raises intriguing prospects about the capabilities of extraterrestrial civilizations. Imagine a civilization so advanced that it can harness the power of a whole star to support its technological advancements and life. This idea sparks interest in the possible scale of extraterrestrial developments and the boundlessness of their scientific achievements. While the disclosures from Congress hearings provide enticing glimpses into the possibility of extraterrestrial presence, the lack of substantial evidence and first-hand experiences remains a concern. Huge obstacles for boundless acknowledgement. Individuals keep on hooking with the test of accommodating these uncommon cases. With the shortfall of direct verification, the actual idea of these disclosures, suggestive of science fiction stories, adds a component of vulnerability and skepticism among the general populace. The conversation about outsiders is continuous, and there's a split among researchers and the general public concerning whether these cases are valid. Later on, new proof or mechanical advancement could help us see more about outsiders and how they could influence infinite events. Until further notice, whether or not we're the only ones in the universe remains an enamoring secret, interesting those curious about the possibility of life beyond Earth. Dyson's hypothesis may be conceivable, but the presence of outsiders is dubious. To outfit 771 trillion stars, there would have to be at least 1 billion civilizations. However, this hypothesis falls short in making sense of the vanishing of stars. Researchers are perplexed, unable to find a reasonable explanation, adding to the mystery. The James Webb Space Telescope has uncovered a baffling peculiarity in the far-off universe. In the winding galaxy NGC 5584, found 75 million light-years away, there are throbbing stars surrounding it that shouldn't exist. This revelation challenges our central comprehension of the universe. It suggests that the universe is growing quicker than our current models, clashing with the notable Hubble constant. The Hubble constant, named after astronomer Edwin Hubble, is a critical figure grasping the universe's extension. It relates the speed of cosmic systems to their distances. For example, a Hubble constant of 50 suggests the universe is extending at a pace of 50 kilometers per second. Edwin Hubble, utilizing the world's biggest telescope, observed the universe's extension and presented this constant, exhibiting the straight connection between the distance and speed of systems. The new disclosures have left researchers astounded, questioning the very fabric of our understanding of the universe. Hubble was the trailblazer in presenting the idea of the Hubble constant, but there exists an absence of agreement among researchers concerning its real essence. Different approaches have been attempted to unwind this mystery. One such method involves investigating specific areas in space and determining their distance from us. For example, researchers select a far-off star within the Andromeda Galaxy and observe the changing distance between Earth and that star over the course of a year. This observational strategy enables them to identify the rate at which the universe is growing. One more road of investigation involves concentrating on a peculiarity known as the cosmic microwave background, CMB. The CMB isn't just a setting of light, it also has a quantifiable temperature. As the universe undergoes expansion, the temperature of the CMB diminishes. Researchers have noticed a decrease of roughly 2 degrees over a span of 10 years, recognizing the connection between the cooling of the CMB and the expansion of the universe. Researchers use this data to assess the elusive Hubble constant. However, there's an issue. These two methods never agree on the Hubble constant. Researchers call this conflict the Hubble tension. They don't know why the techniques give various responses. Currently, there's a new twist. The James Webb Space Telescope is showing that perhaps both methods were wrong from the start. It suggests the universe is growing much quicker than we thought. In simple terms, Hubble started this thought, but researchers are quarreling over how fast the universe is developing. They utilize two methods for estimating it, however, these ways disagree. Now, a new space telescope is implying that they might both be off. It's somewhat of a riddle in the science world. Our understanding of the universe gets a bit confounding when we realize that researchers keep fundamentally altering the manner in which they consider it based on new data. At first, these changes appear to be necessary, but now they seem more like quick fixes for problems in the Big Bang theory. The James Webb Space Telescope has recently shown us things that make us question the way we normally ponder the universe. It's vital to know that the way we currently understand the universe goes back to a major revelation by Edwin Hubble in 1929. Hubble saw that galaxies far away from Earth appeared to be moving away faster, suggesting that our universe is expanding in all directions. Ideas like dark matter and dark energy were created in light of Hubble's discoveries. There have been changes along the way, like adding the concept of cosmic inflation. The Big Bang theory suggests a rapid expansion in the first part of a second after the Big Bang, ensuring a smooth and homogeneous initial growth. However, loopholes continued, resulting in the multiverse hypothesis, proposing a limitless number of universes. In spite of these endeavors to explain our universe's evolution, the latest Webb discoveries challenge the validity of the theory of the universe's origin and subsequent changes. Many researchers believe it's time to change how we understand the universe. They trust we ought to stop using the former method of thinking called the Standard Model and start anew. When the Standard Model was created, we didn't have powerful resources like the James Webb Telescope. This makes some researchers think we should let go of old ideas and create a totally new model. Additionally, astronomers and cosmologists agree that we need a better approach for thinking. However, getting everybody to settle on it is hard. It's a challenge to ensure the entire academic community is on the same page. But we can't simply overlook the fundamental principles of physics as we seek new answers. Regardless of whether the theory of the Big Bang turns out to be incorrect, researchers have few options. They need to adhere to it until a better, more developed and widely accepted thought comes along, and there's nothing more to it. For now, gratitude for tuning in today. Watch out for our impending recordings. Stay connected and be sure to hit that subscribe button and the bell icon so you never miss an update. Until sometime later, fare thee well.